Indeterminate forms are mathematical expressions that cannot be determined from the given information. They often arise in limits, calculus, and other areas of mathematics. Common indeterminate forms. 1, 0, 0. This occurs when both the numerator and denominator approach 0. 2, infinity/infinity. This occurs when both the numerator and denominator approach infinity. 3, infinity, infinity. This occurs when two infinite quantities are subtracted from each other. 4, 0 * infinity. This occurs when one quantity approaches 0 while the other approaches infinity. 5, 1 * infinity. This occurs when a quantity approaches 1 while the exponent approaches infinity. 6, infinity * 0. This occurs when a quantity approaches infinity while the exponent approaches 0. 7, 0 to the power of 0. This occurs when both the base and the exponent approach 0. Examples. Lim x 0 sin x, x. This is of the form 0, 0, but using L'Hopital's rule, we can determine the limit to be 1. Lim x infinity x * 2 e * x. This is of the form infinity/infinity, but using L'Hopital's rule, we can determine the limit to be 0. Lim x infinity open parenthesis 1 + 1 divided by x close parenthesis to the power of x. This is of the form 1 * infinity, but using the definition of the natural logarithm, we can determine the limit to be e. Handling indeterminate forms. L'Hopital's rule. This rule can be used to evaluate limits of indeterminate forms that are of the form 0, 0 or infinity/infinity. Algebraic manipulation. Sometimes, algebraic manipulation can be used to simplify an expression and remove the indeterminate form. Taylor series. Taylor series can be used to approximate functions and evaluate limits. Numerical methods. Numerical methods can be used to approximate limits, but they may not always be accurate. It is important to note that not all indeterminate forms can be evaluated using these methods. Some may require more advanced techniques or may not have a definite limit.